Integration by parts examples. This video assumes that you know basic integration techniques and that you know how to do U substitution. So when we look at questions that require integration by parts, like number 1 right here, you instinctually might think about U substitution first, and we might think maybe let's let U equal 5x. That means du is 5 dx. But we have this extra x in there. So that's our clue that U substitution does not work. So we are going to use integration by parts. Here over on the right is our integration by parts formula. The left side is your original problem, and the right side of the equal sign is what you are going to do. So on the left side, we have U and we have dv. That means for each problem, we need to look at our original problem and decide what we're going to make U equal and what we're going to make dv equal. So let's try it. A little hint, a lot of times if you have an x or an x squared or something like that, that is going to be your U, and I'll show you why in a second. So I'm going to make cosine of 5x dx your dv. Now on the right side of the equation, I want U, I have my U, that's x. I also want v. So keep in mind or notice, if I integrate dv, I get v. So I want to integrate both sides of my dv equation, and that's going to give me what v equals. So that's going to help me fill in this v. I'm going to have v again, and then I have du. So just like U substitution, I'm going to take the derivative of both sides of my U equation, multiply both sides by dx, and I get du equals dx. So long story short, choose U and dv, integrate dv equation, take the derivative of the U equation. Let's finish our integration. Notice here we are going to have to use U substitution, so I'm going to let U equal 5x, and du is going to be 5 dx. So that means we need a 1/5 out front. We get 1/5. The integral of cosine is sine. And when I plug 5x back in, I get 1/5 sine of 5x. Now I know this is an indefinite integral, so normally we would be putting plus c. Don't worry about it for right now. We are going to have plus c at the very end of our problem. So the way I do it is I know I'm going to have u times v, and then inside the integral, I'm going to have v du. So I kind of draw these little swooshes. So I'm going to say my original problem equals u times v is x times 1/5 sine of 5x. So I'm going to write it like this, because we normally put the 1/5 before the x. And then I have my minus. And then I'm going to integrate v du. So this is going to be 1/5 sine of 5x, and then my du is dx. Okay, from here, now I want to integrate what I have left over after doing my integration by parts. And the goal is that once I get to this step, I have something that's easier to integrate than what we started with. If this gets harder, then maybe we need to go back to the first step and choose a different u and a different dv. So let's integrate this. First thing I'm going to do this in a few steps. I'm going to copy down my first term. I'm going to pull out the 1/5 because that's not going to help us. And we are going to do u substitution again. U is 5x. That makes du 5 dx. So I need 5 dx, which means I need another 1/5 out front. Simplify a little further. Minus 1/5 times 1/5 is 1/25. And the integral of sine is negative cosine. So I'm going to make this negative a positive cosine, and then when I plug back in for my u, I get cosine of 5x, and then here make sure you do your plus c. So there is our first example. Okay, number 2. So now we have r's instead of x's, which is totally fine. We're going to treat it the same way. We are going to be doing integration by parts, so I need to start by choosing a u and choosing a dv. Now, similar to the first question, I had an x in the first question. I have an r in the second question. Now, generally, I want to choose r to be my u, because when I take the derivative of r, I get the dr once I multiply the dr to the right side. So when I get my integral over on the right side, that means it's going to be easier. So if taking the derivative of it makes it a nicer variable or number, we're going to make that our u. That's a general rule. I'm going to make my dv then e to the r over 2 dr. Just like before, I want to integrate both sides. I get v equals, we need u substitution again. I'm going to make u equal to r over 2. That makes du 1/2 dr. So I need this to be 1/2 dr, which means we need a 2 out front. The integral of e to the x is just e to the x. So this would be e to the u. And then when I plug my u back in, I get r over 2 as my exponent. So my next step, I'm going to do u times v. So that's going to be, I'm just going to kind of write it in a different order. 2 times r times e to the r over 2. That was my u times v. Minus, then I'm going to do v du. So integral of 2e to the r over 2 dr. And notice now my integral is nicer. I can actually do this one using u substitution. So it's actually going to be the same rules as this one right here. So I want 1/2 dr, so I'm going to put another 2 out front, copying that first term, minus, I'm going to do 2 times 2, which is 4. And then this is e to the u du, so we're just going to go straight to the answer. That's going to be e to the u, but replace your r over 2 back in. And then we're going to have our plus c. And that is that answer. Let's do another example. So example 3. Again, we need to choose our u and our dv. So u needs to be something that we can take the derivative of. dv needs to be something that we can integrate. Now, as of right now, we don't know how to integrate natural log. We're actually going to do that for example 4. So since I don't know how to integrate natural log right now, I'm going to make that my u, and that would make the square root of x dx my dv. So I need my du and I need my v. Derivative of natural log of x is 1 over x, and then I have my dx. Integrate both sides. I get v on the left. On the right, keep in mind that this is x to the 1/2. So I get x to the 3/2, 2/3 out front. All right, so I want u times v. So that's going to be 2/3 x to the 3/2 times natural log of x, minus, in the integral I have 2/3 x to the 3/2 times 1 over x dx. So let's clean up what we have in our integral. I'm just going to copy down my first term again, and I'm going to bring the 2/3 out front. Keep in mind that x to the 3/2 times 1 over x, that's x to the 3/2 over x to the 1, which is 2 over 2. So this is the same thing as x to the 1/2. And we can integrate that. So again, copying down my first term. Okay, if my 2/3 from out front, integrate x to the 1/2, we're going to add 1 to the exponent, so it's going to be 3/2. Flip it, I have 2/3, and don't forget your plus c. Last step, I'm going to do 2/3 times 2/3, which is 4/9. and that is my final answer. All right, last problem. Let's integrate natural log of x. Gonna move it up a little bit. So let's choose our u and our dv. Now for this, dx always has to go with dv because I can't integrate unless I have a dx or a dv or a d something. So the only thing that's left to be my u is my natural log of x. So sometimes it works out that way. Take my derivative. Derivative of natural log is 1 over x, and I have my dx. When I integrate both sides for my dv, I get v equals x. So I want u times v. That's going to be x times natural log of x minus, for my integral, I'm going to have x times 1 over x dx. I'm going to continue. Let's simplify what's in my integral. X times 1 over x is the same thing as 1. So I'm integrating dx. And when I integrate dx, I'm just left with x. And don't forget your plus c. So that is your answer. And this is 4 examples of integration by parts.